Welcome back. So today we're talking about trapezoids. A trapezoid is another type of quadrilateral, but this time it has exactly one pair of parallel sides. The parallel sides are called bases, and the non-parallel sides are called our legs. So similar to a triangle, we have legs and bases, but for a trapezoid we have two bases. A base angle is formed by a base and a leg. We also have what's called an isosceles trapezoid. For an isosceles trapezoid, the two legs are congruent to each other. So then with our isosceles trapezoid, we have a couple theorems, some different things that we know about them. For an isosceles trapezoid, both pairs of base angles are congruent. So if you look in the picture that I have over here, we have our base angles are formed by a base, which are the parallel sides, and one of the legs. So we have A and B are congruent to each other, and angles C and D are congruent to each other. We also know that the diagonals for an isosceles trapezoid are congruent. So we have our diagonal BD is congruent to our diagonal AC. Okay? Alright, so then the next piece is a median. Trapezoids also have what's called a median. A median is a segment that joins midpoints of the legs of a trapezoid. Okay, so the median is also called a mid-segment. You may remember back in semester 1 we spoke about a mid-segment. So this is the same thing. A median is parallel to the bases, and it's half the sum of the two bases. So what that means, my two bases, I have A, B, and C, D. If I add their lengths together, okay, so I'm going to add them together and divide by 2 or multiply by 1/2, I will get EF. Okay, so I'm just adding these together and dividing by 2. Okay? Alright, so let's move on and do some examples then. So we have our first example here. So we have quadrilateral JKLM. It has vertices of J is at a -18, -1, K is at a -6, 8, L is at 18, 1, and M is at -18, -26. And we're going to verify that this is a trapezoid. So if you remember, we said a trapezoid has exactly one pair of parallel sides. So that's what we're going to be working with here. Just like we did before, we're going to be dealing with our slope. So we're going to find the slope of JK. We're going to find the slope of JM, slope of KL, and the slope of ML. Okay? Alright, so if you remember slope, we're doing y's on top. So for J and K, we're looking at our two coordinates. So we have -1 -8, and our x's, -18 minus a -6. Okay? Alright, so then a -1 minus 8, we end up with a -9 divided by -18 minus a -6. Minus a negative is like plus. So the difference between 6 and 18 is 12, and that's going to be a -12. So then from here, negative over a negative becomes positive. 9 over 12 is 3/4. Okay, let's go on to KL. KL, we have 8 minus 1 divided by -6 minus 18. 8 minus 1 is 7. -6 minus 18. Now we're going to add these together. Excuse me. So we get -24. And I'm actually going to be leaving this one this way. Okay, because we can't really simplify it any farther than that. So let's look at JM next. J and M. We have a -1 minus a -26. Divided by a -18 minus a -18. -1 minus a -26, we're adding here, so that means we're going to take the difference, which is 25, positive 25, a negative 18 minus a negative 18. Again, minus a negative is like plus, so we have 0 on the bottom. So this is going to be undefined. So then our last one is ML. So we're going from M to L. So our y's are first, 1 minus a negative 26 over our x's, 18 minus a negative 18. We end up with 27 over 36. For our 27 over 36, we're just going to simplify that down, and we actually should get 3/4. 9 goes into both of those. Okay? Alright, so then we're going to be looking at our different slopes and seeing if we have parallel sides. Well, I see JK and ML both have 3/4. So JK is parallel to ML. The other two are not parallel. JM not parallel to KL. So one pair of parallel sides. So since it has exactly one pair of parallel sides, so we know J, K, L, M is a trapezoid. Okay? Alright, so moving on to the next piece. We're going to determine whether JKLM is an isosceles trapezoid. So if you remember, an isosceles trapezoid means that our legs are the same length. So we're going to be using distance formula this time, and our legs are the non-parallel sides, so that's JM and KL. So JM and KL are the ones we're using our distance formula for. Okay, so we're going to be looking at those coordinates again. I'll slide up here just a little bit. So J to M for our distance formula, we're going to be taking a negative 18 minus a negative 18. And yes, I know you can't see what I'm writing very well. I will slide up here. I just wanted you to be able to see the coordinates that we're using. So it's negative 18 minus a negative 18, and that's squared, plus our y's, we have a negative 1 minus a negative 26 squared. And then for KL, I'll go ahead and slide up here. So then for KL, when we're looking at those, we're going to be using a negative 6 minus 18 squared plus 8 minus 1 squared. So then we're going to go ahead and solve those, and in order for it to be isosceles, again, they have to be equal. So a negative 18 minus a negative 18, we end up with 0, plus a negative 1 minus a negative 26 gives us 25, and that is squared. So we end up with square root of 625, which equals 25. For KL, we're going to be taking the negative 6 minus 18, so we should have a negative 24 squared, plus 8 minus 1 is 7 squared. So we have 576 plus our 7 squared is 49. So we end up with 625. Square root of that is 25. So legs are congruent. So JKLM is an isosceles trapezoid. All right. Great job with that. Let's go on to another one here. So for this one, we have QRST as an isosceles trapezoid with a median of XY. We're going to find TS if QR is 22 and XY is 15. Okay, so from here, we have QR, it says is 22. It tells us XY is 15. So we're trying to find this other base. And if you remember, I said we're adding the two bases together. So we should have 22 plus TS divided by 2 equals our median, which is 15. Okay, so the first thing I'm going to do here is I'm going to multiply by 2 on both sides. So we have 22 plus TS equals 30. So then from here I'm going to subtract my 22 from both sides. I get TS equals 8. Okay, and we can check that by just adding them together. 22 plus 8 divided by 2, 22 plus 8 we said was 30, so we get 15, which is supposed to be our median. So we found TS to be 8 units long. Okay, that was dealing with our median and mid-segment. So then the next part says we're going to find the measure of angle 1, 2, 3, and 4 if we know that the measure of angle 1 is 4A minus 10 and the measure of angle 3 is 3A plus 32.5. So how do these all work together? Because we have angle 1 and we have angle 3. We know, since this is a quadrilateral, that all of the interior angles should equal 360. We also know that 1 is equal to 2 and 3 is equal to 4. So if I take 2 times the measure of angle 1, which is 4A minus 10, plus 2 times the measure of angle 3, which is 3A plus 32.5, I should get 360 because that would be all 4 of my angles. Okay? So I'm going to go ahead and slide up here so I can solve for A. So I'm going to distribute first, so I get 8A minus 20 plus 6A, just distributing these, 6A plus 32.5 times 2, we're going to get 65 equals 360. So combining like terms, 8 plus 6 gives me 14A. Negative 20 plus 65 is a positive 45 equals 360. So now solving, subtract 45 from both sides. 14A equals 315. Dividing by 14 on both sides. We end up with A equals 22.5. So then from here we're just going to be plugging it back in so that we can get our different angles. So we said angle 1 is 4A minus 10, so 4 times 22.5 minus 10. So we're going to end up with 90 minus 10 equals 80. So that's angle 1. For angle 3, we have 3 times 22.5 plus 32.5. So when we take 3 times the 22.5, I'm getting 67.5 plus 32.5. So I'm getting 100 equals angle 3. And like I said, we know that angle 3 is equal to angle 4, and angle 1 is equal to angle 2. So I have angles 1 and 2 at 80, 3 and 4 at 100. And again, if you add all of those together, you should get 360 degrees because it is a quadrilateral. Okay? Alright, that's all I have today. I'll see you in class tomorrow.